or carbon steel rod. The rod can be flexed easily in the hand, and you can see how elastic it is. When the rod is heated in a furnace to red heat, then cooled as quickly as possible in water, it will become hardened. So hard, in fact, that a file won't make any impression on the surface. It'll just skid over it. But unfortunately, the rod has now become brittle. In this second experiment, an identical rod is heated in the furnace to the same red heat. Then it's cooled very slowly by immersing it completely in vermiculite, a process known as annealing. The metal will now have good ductility and will be soft. You can mark it with a file with no trouble at all. It'll also bend easily, but after bending, lacking elasticity, it remains bent. In a third experiment, the rod is again heated to the same temperature, and then it's quenched rapidly in water. That makes it hard and brittle, just as in the first experiment. Then the rod is put back into the furnace, and this time heated to a lower temperature. After this, it's cooled slowly in vermiculite. It could also be cooled in air. This process of heating and cooling is known as tempering. It's a carefully controlled compromise between toughness and hardness. The rod doesn't mark too easily with a file, and it can be flexed in the hand. The extent to which any steel may be hardened is largely dependent on its composition when it was made in the furnace. The amount of carbon present is most important.